Hello and welcome. This is Cambridge O-Level Physics paper number 1, multiple choice. The subject code is 5054. This is May-June 2020 exam, and this is the variant 1 for this exam. Let's start. First question, it says the diagram shows the resultant R of a 3 Newton force and a 4 Newton force that acts at a point P. The angle between 3 Newton and 4 Newton force can be of any value from 0 to 90 degrees. Which value of R, that is the resultant, is not possible? Okay, so let's see. So if the value is 0 uh, between 4 Newton and 3 Newton, so 4 Newton is here, so 3 Newton is this, 4 is this, the resultant R will be 4 plus 3, 7 Newton. So this is case when theta equals to 0 or the angle between 3 and 4 is 0. And the other case or the worst case is when the angle is 90 degrees. So this is 3 Newton, this is 4 Newton, and using the parallelogram law or just this vector or the vector addition of two vectors. So this R vector will be under root 4 square plus 3 square. So answer will be 5 newtons. So the maximum value will be 7 newtons and the minimum value will be 5 newtons. So any value other than that, or so the range we have is 5 less than equal, so R 7 equal. So R can be equal to 5 and R can be equal to 7. So anything beyond this range is fine. So 7 is possible, yes. 6 is possible, yes. 5 is possible, yes. 4 is possible, no. So answer A is the right answer. Next question. Question number 2, it says what is measured using a micrometer? So micrometer is used to measure the length. Okay. So area, no. Current, ammeter is used to measure current. Length, yes. Mass, no. So answer C is the right answer. Question number 3, the graph shows a short journey. It is the speed time graph. Okay, so on the y-axis we have speed in meters per second. On the x-axis we have time in meters per second. What is the greatest speed reached? Okay, so in this graph, the greatest speed reached is this. So this is 3 meters per second. So the greatest speed reached, the answer is C, 3 meters per second. Next question. It says the car, question number 4, it says the car of weight 11,000 Newton moves at constant velocity along a horizontal road. The driving force 5,000 Newton acts on the car. What is the opposing force on the motion of the car? So for example, you have this car, something like this, and this is moving. So the weight of the car is 11,000 Newtons and driving force driving is 5,000 Newton. So basically the driving force is the overall effective force that is making the car drive, and that is that comes after adjusting for the friction and everything else. So what is the opposing force motion or opposing motion on the car? So remember, opposing force, the reaction force acting is equal to minus the driving force, and that is equal to minus 5,000 Newton, and minus sign is basically showing the direction or the opposite direction that is acting. This is the F opposing or the reaction force that occurs because of this driving force. So the answer A will be the right answer. Okay. Next question. Question number 5, it says a man with a open parachute falls to earth at constant speed. The following forces act. Number P. Number 1, P, force P, the upward force on the parachute of the man. So for example, let's draw this picture, and in order to have this a better. So this is man, so this is a parachute, that is, and it is so upward force on the parachute, upward force of the parachute on the man. So man, there is a force P that is acting. Q, upward force of man on the earth. Okay, so upward force of man on the earth, Q. Okay, the downward force of Earth on the parachute. So this is by Earth on the parachute. The S, the downward force of man on the parachute. So the man is on the parachute that is acting, it is S. So which two forces are Newton's third law pair? So remember, since it is not, you can say it is in terminal motion at the moment. So technically what is happening is that the man, uh, that this force P and this force S, the downward force of the man on the parachute is equivalent to uh, P, the upward force of the parachute on the man, and that basically causes the parachute to move at terminal speed or a constant speed towards the earth. Upward force on the man of the man on the earth and the downward force of the earth on the parachute, I mean, these are not the Newton third law pair at the moment. So answer C will be the best choice we have. Then question number 6, it says a box is pulled up a rough slope as shown. So this is a slope, and in which direction does the friction act on the box? So this in this direction, if we are pulling it up, the friction will be acting in this direction. So Fr, so friction force will be acting in this direction. So answer D, or the force that correspond to this direction, will be D. So this is the right answer. Next, question 7, it says the diagram shows a motorcyclist leaning over in order to turn the corner to the left. Which forces cause him to turn? So the, the motorcyclist is turning, and remember that if in a circular motion, if a body is moving in a circular motion, this is the direction of motion, and if it is turning, the force or the centripetal force is the force that allows, or that is the one that is responsible to move this body in a circle. So anything, so it is moving towards left, and there would be a force towards the center of this, whatever the circle this guy is making. So this force A is the only force that is moving towards the left side and towards the center of the circle. So the answer A will be the right choice in this case. Okay. Then question number 8. Question number 8 says, which type of forces causes the earth to orbit the sun? Elastic force, are you joking? No. Electrostatic, not at all. A magnetic force, no. Gravitational force, yes. So that's the gravitational force that allows, or that causes the earth to move around the sun, or for that matter any other planet to revolve around the sun, and all the heavenly bodies are basically governed by the gravitational force. Okay. Next, question number 9. It says 4 objects of different masses are on different planets. The weight of each object on its planet is determined. Okay. Which of the object is on the planet with the smallest gravitational strength? Okay. So remember, weight is equal to mass times the gravitational constant. Okay. So if we have to find out, make another column of G over here and calculate the values. So if and for calculating the value of G, you have to divide the weight divided by the mass. So this 125 divided by 5, this comes out to be 25. 150 divided by 15, this comes out to be 10. 220 divided by 20, this again comes out, this comes out to be 11. And this is 225 divided by 25, and this comes out to be 9. So which object is on the planets with the smallest gravitational field strength? So the answer is D. So because 9 is the, or G is basically the gravitational field strength. So 9, the value D is the object which is on the planet with the smallest gravitational field strength. Okay. Next question. Question 10, it says, which physical quantity does not change when piece of copper is heated? Okay. So remember, a metal is heated. So first of all, is the density changes? Yes, the density does change when heating. So mass changes? No, mass is a universal or an inherent property. The mass of anything remains constant. Temperature, yes, I mean, if you heat something, the temperature will change, or basically will increase. The volume of the substance will change. Yes, a metal expands, generally expands on heating, so yes, volume will change. So the answer B is the right choice we have. Next question. Question 11, it says a single metal bolt has a mass of 34 grams. Three bolts are immersed in a measuring cylinder that contains 30 centimeter cube of water. The reading on the measuring cylinder rises to 42 centimeter cube. What is the density of the metal? So remember, density is equal to mass per unit volume. So this is mass and this is our density. Okay, so the mass is given to us is 34 grams. Then we have three bolts. So we have three bolts immersed in a measuring cylinder. So initial volume initial is 30 centimeter cube. Volume final is 42 centimeter cube. So change in volume, delta V is 12 centimeter cube. And this is volume for three bolts. So volume of one bolt is equal to 12 divided by 3, 4 centimeter cube. So then use this volume and mass. So mass is 34 divided by 4. So this value comes out to be 34. Let me divide it. Mm, 34 divided by 4. So this comes out to be around 8.5. It's good to cross check. So it is 8.5 grams per centimeter cube. So this value is in grams, this value is in centimeter cube. Okay, so this is how you solve this. Next question, question 12. It says a rocket of mass m when empty carries a mass m of fuel. Okay, the rocket and fuel travels at a velocity v. The engine of the rocket is fired and all the fuel is expelled. The speed of rocket increases to 2v. What happens to the kinetic energy of the rocket? Okay, so initial, so if consider that we have a rocket like this. So mass of rocket, we call it mr, is m, and mass of fuel, it is mf, you can call it m. And and it is traveling with a velocity, v, or speed v. Okay, then the engine of the rocket is fired and all the fuel is expelled. So the rocket, technically the fuel is consumed. The speed v2 is now 2v. So the new speed is 2v. And it says what happens to the kinetic energy of the rocket. So basically, there is a trick in this question. So initially, they are only asking about what happens to the rocket, not to the mass. So initial kinetic energy, the initial Ke of rocket. So initial kinetic energy of rocket is half mass of rocket only, mr. So mass of rocket only is m into velocity mv square. Okay, then final kinetic energy of rocket, and remember rocket only, not rocket plus mass. So this is one of the issues, or one of the problems which most of the students made in this exam. So they basically did m plus m, 2m, and then that all messed up this question. So it's only considering the rocket. So that is why your marking scheme always give you the answer which is over there. So final kinetic energy, remember the mass of rocket is m and new velocity is 2v. So half mv square. So this is 4 times half mv square. Okay, so this is half mv square. This is 4 times half mv square. So it increases by a factor of 4. This is how it goes. So answer C will be the right answer, and that is what your marking scheme is saying. Remember, the students are making this mistake that they calculate the initial kinetic energy of rocket plus mass, and that is how they calculate it, and that comes out to be half 2m v square, and in this case they have m or mass v square, and that when that basically comes out to be this, so they say that the the kinetic energy doubles. So doubles is not the answer, they are only asking about the rocket, and that is the catch in this whole question. Okay, so this is remember, when you are doing this, this is not the right approach. Next, question number 13. It says a car of mass 1000 kg is driven 200 meters up an incline, so it rises 50 meters vertically. The acceleration of free fall is 10 meters per second square. What is the potential gain in potential energy? So remember, the car is here, it's gain here. The potential energy at this point is mg times h. So mass of the car 1000, kinetic energy 10, height is 50. So if you multiply all of these together, the answer comes out to be C, right? So it is 500,000 joules. Next question, question number 14. It says a fish is swimming 15 meters below a lake as shown. The density of water is 1000 kg per meter cube. Atmospheric pressure is 100,000 pascals. The acceleration due to gravity is 10 meters per second square. What is the total pressure on the fish? So remember, the total pressure on the fish will be rho gh plus atmospheric pressure. So this is the atmospheric pressure that is coming, and the pressure because of water, or because of depth of water. Okay, so this is the pressure. So what is the total pressure? Rho density is 1000 kg per meter cube, multiply by 15, multiply by acceleration due to gravity 10. Remember, the units must be consistent, plus 100,000 pascals. So remember, this is also in pascals and this is also in pascals. So overall, the answer comes out to be, if you're going to add these two values, it comes out to be 250,000 pascals. So answer D is the right choice we have. Next question, question number 15. It says the diagram shows a mercury manometer. The tube is open to the atmosphere on the right hand side. So this is the atmosphere pressure that is coming over here. And the left side is connected to the container containing a gas at a pressure P. So atmospheric pressure on its own supports a column of mercury. So remember, P ATM is 756 millimeter of Hg, and which height of the column does pressure P on its own support? Okay, so which height of the column on its own support? So remember, so this is the pressure because of P, and this is the pressure because of atmosphere. So overall, this is the height that is or that is because on the, or whatever the pressure is less than atmosphere or greater. So I mean, it is less than atmosphere pressure. So this is 60 centimeters millimeters of Hg above the baseline. So the height of column, which height of column does pressure P on its own support? So this pressure P will be 756 millimeters of Hg minus 60 millimeters of Hg. So if we are going to subtract these two values, it comes out to be 696 millimeters of Hg. Hg is, remember, mercury. 676 no, 696 yes, 816 no, it is this next. So this is the right answer. Answer B is the right choice we have. Then question 16, it says the weightlifting contest, an athlete lifts a metal bar of mass 20 kg fitted with a mass of 80 kg on each end. The lift from the ground to a height of 2.5 meter takes 0.5 seconds. The gravitational field strength is 10 Newton per kg. What is the average power does the weightlifter exert in providing gravitational potential energy to this lift? Okay, so average power, uh, or so remember, energy equals to power multiplied by time. So energy or calculate the potential energy at this point. So potential energy is mgh. So total mass is 20 kg plus 80 kg on the sides, multiplied by 10, multiplied by 2.5. So this comes out to be, let me do the calculations, 100 multiplied by 10 multiplied by 2.5, and so the potential energy, so technically, so sorry, so there are two 80 kgs lying. So this is one more, so 80 plus 80, so 160. So let me do it again. So this is 160, 180 multiplied by 10 multiplied by 2.5. So 180 multiplied by 10 multiplied by 2.5. This is 4500 joules. And power equals to energy per unit time. So 4500 joules divided by 0.5 seconds, it comes out to be 9000 watts or 9 kilowatts. So answer D is the right choice we have. Okay, this is how you solve this question. Next part, question number 17. It says a boy is standing on the side of a lake. The boy drops a heavy stone from a height 2 meters above the surface of water. The acceleration due to gravity is 10 meters per second. What is the speed of the stone when it hits the surface of the water? Okay, so at this point, remember the stone has some potential energy, and at this point, the stone have total uh, kinetic energy. So this whole potential energy converts to the kinetic energy. So potential energy at this point is mass of the stone. So m, okay, I take it as m, height 2, acceleration due to gravity is 10. So it is 20 m times joules, and that is equivalent to 20 m, half mv square. So this m cancels out each other. V square is 40. So under root of 40 is the velocity, and under root of 40 comes out to be approximately equals to 6333 meters per second or something like that. So 6.3 is the right choice we have over here. Okay, next question. Question 18, it says, in which situation is the energy released by the fusion of hydrogen nuclei from helium? Number one, the decay of carbon-14 used to detect date an object. No. In radioactive isotope emitting alpha particles. No. In the center of the earth. No. In the center of the sun. Yes. Answer D is the right choice, because that is the reaction that is taking place in the sun. Next, question number 19. The diagram shows a block being pulled up by a slope pulled up a slope by a force F. The block reaches the new position at the top of the slope. Okay, so this is the new position. What is the work done by the force F in moving the block to its new position? So remember, work done is force multiplied by distance traveled in the direction of force. In the direction of force. So remember, the force is F and the distance traveled in the direction of force is R. So F cross R. A is the right answer we have in this case. Okay. Next question. It says, question 20, which statement about mercury in glass clinical thermometer is correct? Number one, it covers a much larger range than an ordinary laboratory thermometer. So no, so ordinary laboratory thermometer is generally from 0 or say -10 to 100 degrees centigrade, whereas the ordinary clinical thermometer is just a small range of these values. So no, this is not the right answer. Number two, it is more sensitive than the ordinary laboratory thermometer. Yes, it is more sensitive because it is a clinical thermometer and we have to, measure the temperature with some much precision. Then C, it says the scale is not linear. No, the scale is linear. So this is not the right answer. Its sensitivity is affected, option D, its sensitivity is affected by the constriction in the capillary tube. No, the sensitivity is not affected by the constriction in the capillary tube. So answer B is the best choice we have in this case. Next question. Question 21, it says which description of dull black surface is correct? Uh, Good emitter, good absorber, good reflector of radiation. So remember, dull black surface, good absorbers, yes. Good reflectors, no. Good emitters, yes. So they are good emitter, poor absorber. Again, this is not the right answer. Good emitter, good absorber, poor reflector. Yes. So answer C is the best choice we have. Poor emitter, no, they are good emitters. So answer C is the right choice we have. Then question 22, the temperature of a body increases by 1 degree centigrade. Which other quantity also increases? Okay. Remember, heat capacity, no. So the heat capacity of a body is the amount of heat required to change the temperature of the body. So no, heat capacity remains the same. Internal energy, yes, internal energy is a factor of temperature, and if temperature increases, the overall internal energy increases. So yes, this increases. A specific heat capacity, specific heat capacity is the amount of heat required to raise the temperature of a body by 1 degree centigrade. So specific heat capacity is constant for a uh, of an object. Remember, so same as heat capacity is constant again. So this does not increase, it remains constant. Again, specific latent heat. Again, specific latent heat is the amount of heat required to change the state of the of a body or a material or a substance. Again, it is a constant for a material, and this does not change as well. So answer B is the right choice we have. Then question number 23, it says the thermal energy produced by an electric heater in 3 minutes is used to melt wax. The solid wax is initially at its melting point of 60 degrees centigrade. The specific latent heat of wax is 220 joules per gram. The heater supplies 7,700 joules of thermal energy to the wax. Some of the wax melts. How much wax melts? Okay, so this is now an interesting question. So let's uh, try to solve it. Thermal energy produced by electric heater in 3 minutes to melt the wax. The solid wax is initially, so melting point theta is 60 degrees centigrade. Specific latent heat, or you can say L is 220 joules per gram. The energy that is supplied, that is Q 7700 joules, thermal energy to the wax. How much the wax melts? So remember, when wax is melting, it is the change in state of the material. So that is where the specific latent heat comes in. So Q equals to ml is the formula. Q is 7700 mass we have to find, and you have to divide it by 220. So this is joules, and this mass will be in grams. So so mass in grams will be 35 grams approximately. So answer D is the right answer we have. Okay, next question. Question number 24, it says which two rows explains why a liquid has fixed volume, but does not have a fixed shape. So first part is first column is the force between the molecules in the liquid, and number two is movement of molecules in the liquid. So remember, solids and liquids have considerably large force between the molecules as compared to gases, and the movement of molecules. So in solids, the molecules vibrate against fixed positions, whereas in liquids, the molecules are free to move within the liquid, or basically and that is the reason why they take the shape of the material in which they are shape of the container in which they are poured. So the answer is, so if somebody is saying small forces, no, small forces, no. Vibration across fixed position, it happens in solids. So answer A is the right choice we have. Then question number 25, it says a fixed mass of gas is enclosed in a cylinder by a piston, which is free to move. Which combination of changes to pressure and temperature must increase the density of the gas? Okay, so now that is interesting. Fixed mass of gas is enclosed in a container. by a piston. So remember, P1 V1 over T1 equals to P2 V2 over T2. So the fixed mass of gas changes in pressure and temperature. So we are allowed to basically change the pressure and temperature. And remember, density equals to mass per unit volume. And combination of pressure and temperature must increase the, so we have to increase the density. So if we have to increase this density, we have to decrease the volume. Okay, so we have to increase the uh, density, decrease the volume. Okay, that now, so it is a fixed mass of gas. So P1 V1 over T1 equals to constant. So this is a constant value. So for example, if I increase the pressure and I increase, or you can so we basically need to decrease the volume of this, you can say this, or you can say we have to decrease this volume. So what if, say, I'm going to first of all increase or decrease the pressure. So if I'm decreasing the pressure, what will happen? So if pressure is decreased, the volume will increase to make this upper part constant at um, a constant temperature, for example. But uh, eventually, so this decreasing pressure won't be a good option, because this will uh, make increase in volume we have. So first of all, in order to decrease the volume, what we have to do is we have to increase the pressure. So if increasing the pressure, so P1 V1 equals over T1 equals to constant. So in this case, say if uh, a combination of both is required. So first case, okay, let's do it like this. First case, assume T equals to constant. Okay, for a constant temperature, what happens? So for a constant temperature, P1 V1 equals to constant. So if I increase the pressure, my volume decreases and my overall system remains constant. So increase in pressure is what I need. First case. The second case is assume pressure equals to constant. So assuming pressure equals to constant, we have V1 over T1 equals to constant. Okay. So now if I increase the temperature, what will happen? So in this whole factor, in order to remain this constant, we have to increase the volume as well. So this is not suitable. So what if I decrease the temperature? So if I have to decrease the temperature, we have to decrease the volume. The volume should decrease in order to keep this whole thing constant. So basically what I need is I need an increase in pressure and a decrease in temperature. So a combination of pressure increase and temperature decrease will be the best choice. That is the answer C in this case. Okay. Uh, then next question, question 26. It says light enters a glass block at an angle of incidence and produces uh, an angle of refraction R in the glass. Okay, so this is my angle of incidence and this is my angle of refraction. Several different values of incident of I and R are measured, and the graph is drawn for sine I against sine R. Which graph is correct? So this is air and this is glass. So the refractive index of air and refractive index of glass. So remember, N air sine of theta I is equal to N glass multiplied by sine of theta R. Okay, so from here, if I have to say find out sine theta I by sine theta R, that will be n glass divided by n air. And generally n glass is around 1.5 and n air is around 1. So this is a generic values which are there. So if this is along my y-axis, this is along my x-axis, because sine theta r is on x-axis, this is y on the y-axis. So this is actually the slope. So delta y by delta x will be around, should be equal to 1.5 or approximately equal to 1.5. This is what we have to remember. This is the Snell's law, which I have written. Snell's law. This is what I have written. So let's see which graph says this thing. So slope. So slope of this graph. So this is at 0.5. This is something around 0.75. So and at 0.5, this is around 0.25. At 0.5, this is something around 0.3, and at 0.5, this is again. So this slope is delta y by delta x is 0.75 divided by 0.5. This is 1.5. So again, the first part is the best answer. Again, 0.25 divided by 0.5. This is wrong. Again, this is less than 1. Again, this is also less than 1. So this part A will be the best solution in this case, and that is the answer we'll be selecting. Next, 27. 27 question. A swimming pool is lit by an underwater light. The light array of light is incident on the surface of water. What is the correct path of the ray of light? So this is, remember, this is water, and this is, for example, air. So light ray is basically entering from a denser. So this is a denser medium. This is a rarer medium. So light ray is entering or passing from a denser medium to a rarer medium. Okay. So which part is correct? So this is my incident light. So there will be some sort of reflection of light. So left reflection of light will be there. And what will happen? So denser to rarer, away from the normal. So this is normal. So it will flow something like this. So away from the normal, something on, in this case. So answer B again would not be the case. A is not the right path. Similarly, D is not the right path. So this is the reflected path. So answer C is the best option we have in this case. Okay. Then question number 28, which diagram shows the action of a converging lens on a parallel beam of light? So converging lens basically focuses a parallel beam of light to its focal point on the other side of the lens. So this is basically diverging the beams. No, this is not. This is allowing the beams to pass straight through. No, this is reflecting the beams backwards. No, this is not the right answer. Part D, this is focusing the beam at a point, and this is, we can say that this is the focal length of this lens, and the answer D is the right answer we have. Next question, question 29, it says what feature of red light compared to, what is the feature of red light compared with that of a violet light? Number one, prism deviates red light more. Okay, so prism deviates both red light and uh, violet light. Red light has lower frequency, red light has shorter wavelength, speed of red light in vacuum is smaller. Okay, so let's write down the rainbow spectrum. So VIBGYOR, VIB GYOR. So this is your red light, this is your violet light. Remember, this frequency spectrum is something around 400 nanometers lambda to 700 nanometers. Okay, so 400 nanometers to 700 nanometers. And if we have to write down the frequency, so frequency for and remember, C equals to F lambda. C is constant, so frequency is inverse. So shorter wavelengths will have more frequency. So shorter wavelengths, smaller wavelengths will have more frequency. So the frequency for violet is more, red is less. Similarly, lambda is less, or wavelength is less, and wavelength for red will be more. So remember, prism deviates red light more. So what happens actually is that higher frequencies are deviated more. So violet is more. So red, instead of red, we have violet here. So red light has a lower frequency. Red light has a lower frequency. Yes, we have seen this compared to violet light. Yes, red light has a shorter wavelength. No, has a longer wavelength compared to violet light. The speed of red light in vacuum is smaller. Okay, so the speed of light technically remains the same. That is the constant C we have. So no. So answer B is the right choice we have over here. Next part. Question 30, it says, what is the ratio of the longest sound wavelength audible to human ear to the shortest? So remember, range of sound waves, and that range is 20 hertz to 20 kilohertz. So if I have to find out the ratio, one ratio 20 kilo divided by 20, this comes out to be 1000. So longest sound wavelength, uh, the ratio of the longest sound wavelength audible to human ear. So 1000 ratio 1. So the answer uh, B over here is the right choice we have. Then question number 31, it says ultrasound is used to clean jewelry in a liquid. What another use of an ultrasound? Fiber optic communication? No, generally IR infrared is used. Prenatal scanning? Yes. That is those sunbeds? No, we use UV radiations for that. Telecommunications, again IR, or in is used for telecommunications as well, or because fiber optic communication, telecommunications. Fine. So answer B, prenatal scanning or ultrasound for detecting the state or condition of an unborn baby is the one they are talking about in B. Next question, question number 32. It says bar magnets of and various non-magnetic and bar magnets and various non-magnetic and demagnetized metal bars are placed in different arrangements as shown. Which arrangement do the bars repel? So first, a magnet is placed in front of iron, so it induces opposite poles here and they attract. So no. Copper is a non-magnetic material, so there will be no effect. Again, north is in part C, north is opposite to south, south is opposite to north, so they attract each other. So north in front of north, so they basically repel each other. So answer D is the right choice we have. Then question 33, it says there is a varying current in the coil of a loudspeaker as shown. The loudspeaker is producing a sound. The magnet is clamped. So the magnet is clamped. So the magnet, this electromagnet is fixed. What is vibrating to produce the sound? So remember, cone is vibrating, that's for sure. Then the thing is, this coil is wound on this cone. So when this cone moves to and fro, this coil is wound on the cone, that is not wound on the electromagnet. So this coil also moves to and fro with the direction of cone. So both cone and coil moves, whereas this electromagnet is clamped. The magnet will not move. Coil only. Coil will move, but not alone. Cone will move, but not alone. Magnet doesn't move. So answer D is the right choice, coil and cone. Then 34. Question number 34, it says two insulated and uncharged metal spheres X and Y are touching. A positively charged rod is held near X and the spheres are moved apart. X now has a negative charge. So X now has a negative charge. So negative charge 1, 2, 3, and this move apart, it will be having positive charge. So what is the charge on Y? Equal to this or a one less than this, but positive. Negative and smaller than X, no. Negative and small, same in size as X, no. Positive, yes, smaller than that on X, no. Positive and same in size that of X, because this is how electrostatic induction takes place. Answer D is the right choice. Then question number 35. Question number 35, it says a stationary negative charge in an electric field experiences an electric force in the direction shown. So this is the force that is shown. So, this is left to right. What is the direction of the electric field? So remember, if we have two charge plates, so this is the positively charged plate, this is the negative charge plate. So the electric field is in from positive to negative. And if there is a negative charge, for example, an electron that is coming, and that electron will be pulled towards the positive plate. Okay, so here the force on the negative charge particle is in this direction. So we can say that the positive, it is attracted to the positive side, and this is the negative side, and electric field is from positive to negative. So oh, sorry, I apologize for my bad line. So electric field is in this direction, E field, positive to negative. So the direction of the phi field, to the left, yes; to the right, no; down the page, no; up the page, no. So it is answer A is the best choice, to the left of the left side, from positive to negative. Okay, then question 36. It says a battery consists of three identical cells in parallel. So we have three cells. For example, this is one cell, and this is two cell, and this is three cells. So now these three cells are in parallel, something like this. What is the unit of electromotive force, and what is electromotive force of battery equal to? So unit of electromotive force is the amount of, or the the force amount, or the force required by in moving one charge through the complete circuit. That is called the electromotive force, and the units are joules per coulomb. So units for this: joules per coulomb, yes; joules per coulomb, yes; newton per volt, no; newton per volt, no. Okay, so electromotive forces of the battery is equal to, and in this case, sum of EMF of all the three cells, EMF of one of the cells. So remember, these cells are connected in parallel. So voltage, or you can say this, EMF is equal to voltage. So whatever the EMF of one cell, if they are all collected in parallel, the voltage will remain, or the EMF will remain same. So any one of the EMF of the cells will be equal to the overall EMF of the battery. So answer B is the right choice. If they are connected in series, then the EMF will be equal to the sum of these, but it is connected in parallel. That is why we have selected any one of them. But if the connection is in series, then answer A will be the best choice. So answer in this case, remember, their cells are connected in parallel. So answer B is the right choice. Then question 37, it says a nucleide notation of an isotope of X is A, Z, X. How many neutrons are there in the nucleus? Oh, okay. So remember, A is the nucleon number, and Z is the number of protons. So if A minus Z, the total, so A is basically sum of neutrons plus protons. Okay, and this is number of protons. So number of neutrons, just subtract A minus Z, and you will be getting your number of neutrons. So answer B is the right choice we have. Then question 38, it says radioactivity is used in several activities that take place in hospitals. Which activity never uses radioactivity? Cooking meals? No, nobody cooks meals on radioactive stuff. Diagnosis illness? Yes. I mean, there are a lot of techniques: cancer detection, MRI, and these sort of things. They are done with the help of radioactive isotopes. So yes, this is done. Sterilizing equipment? Yes, radioactive substances are used to ionize or treat equipment to sterilize them. Treating illness? Yes, there is for cancer treatment. The chemotherapy is used, and in which radioactivity or radioactive elements are used, or isotopes are used to kill the cancer cells. So yes, this is true. So answer A is the best choice, that never uses radioactive. You remember, even in the hospitals or around, you do not use radioactive substances to cook your meal. So this is the best answer we have. Then question 39, it says 14C carbon 14 element is given, is a neutral is a natural radioactive isotope of carbon and is present in all living things. It has a half-life of 5,700 years. How old is a bone that is found to have only 1/4 of the natural carbon? Uh, you can say C carbon 14 percentage. Okay, so half-life. So remember, 1/4 is equal to 1/2 power 2. Okay, and half-life is 5,700 years. And in this case, we can see that two half-lives are gone. So half-life is generally the time taken uh, by, or overall, whatever the time capital T is equal to the amount that is remaining, that is equal to 2. And no, sorry, I have uh, written this in opposite fashion. This is the time it will be there. This is the half-life. So if we are going to compare them, so the time it will be 2 multiplied by 5,700, and this is 11,400 years. So answer B is the uh, choice we have. So one half-life, it means that half of carbon. So for example, we have initially one carbon 14 by 6. After one half-life, we are left with half of C by 14, and then after another one half-life, we are left with 1/4 of C14 by 16. So this happens after 5,700 years. This happens again after 5,700 years. So total time has passed is 5,700 multiplied by 2. This is 11,400 years. And this is this is much easier way. But if a problem comes up where we have a few decimal places, or this value comes up in decimal form, so then that is not that easier, but just to have an estimate of that. Okay, so this is how you do this question. So last question, question number 40 of this exam, it says a kettle is connected uh, to 240-volt main supply using a plug containing 13 amperes fuse. The kettle contains water. When the switch is on, the fuse blows. Okay, this happens again after the new fuse is fitted. Someone replaces the fuse with a nail and the kettle works. What might happen as a result replacing the fuse in the nail? So what has happened here is that there is some sort of fault, or there or fault in the you can say the overall wiring, and and that is why the fuse is blowing. What has happened here is that someone replaces the fuse and put a nail there, and that nail can withstand high you know uh, current values compared to the fuse, and that fault is not removed, just a high intensity or high rated element is added to the circuit in order to complete the circuit. So now the kettle will work, but the you can say the danger of person getting electrocuted is still there, because the fault is not removed technically. So part A, a very large current overloads the wiring causing fire. Yes, this is possible. Part B, kettle boils the water less quickly. No, I mean kettle will work perfectly fine. The kettle uses more energy to boil water. No, I mean kettle will using the same energy. The water boils at high temperature. I mean that is nonsense. So answer A is the right choice, because the fault is not properly removed. The fuse has been changed with a nail, and that completes the circuit, and the circuit is completed. And now the circuit do not have any protection. Heavy current is flowing in the circuit, and that may cause breakdown of wiring insulation, eventually causing wires to get fire. So answer A is the right choice in this case we have. So here this is the end, or this is the last question we have for this exam. And I hope you have enjoyed listening this and have understood and have learned something from this video. And overall, I would like to say that I wish you all best of luck for your upcoming exams and your future endeavors. Again, thank you for listening. Take care. Bye bye.